All right. Once again, welcome. Welcome to the Virtual Jug. Welcome back because, well, we had a couple of sessions during this month. We had at Yanaga, I think it was 2 weeks ago already. So today we have a brand new session, and I love it that you are here. And of course, I will start with some, well, housekeeping rules or some admin, however you may call it. First of all, my name is Brian. I am employed by a company called Sneak, but I will be your host today. I will not be presenting. Trust me, you don't want that because today is about a topic that I am very interested on, and we have a far better speaker this time than me about this topic. However, I have to mention that Sneak is our main sponsor. Well, we do a bunch of stuff in security. All fine, because you are here for a certain reason, and that is this session. We're going to talk about sailing and not just sailing as sailing in a boat. No, we're actually going to sail Java 15. And Piotr, who is here with me, will be telling you, and well, in the time frame that's possible, to go a bit deeper into Java 15, what you can and cannot do. So I'm very curious because he did the same thing about previous versions on major conferences like Devox, did 2 or 3 hour deep dives on Java and the newer version. So I know he can talk, and he can talk vibrantly on these kind of things. I want to tell you that today we're going to give away 3 JetBrains licenses. I will do that in the Slack, and it will not only be today, but it will be from today till probably till Monday. It will be in the general channel. I will put a raffle on, and you can win a JetBrains license if you want to. If you don't want to, just don't apply. It's not yet there. It will be there during the sessions or after the session. You will see it as we go. But first, we have to pay attention to Piotr, of course. However, if you have any questions, I urge you to go to the Virtual Jug Slack because, well, I am there, but also Piotr is there. And if for some reasons we are not able to answer your question right away, we can do that afterwards in the Slack channel. So don't do it in the YouTube chat. I know it's there, but please don't. We probably will look at it, but not as much as in the Slack channel because there is where the community lives. It's not only about the videos. If you like this session, please share the URL now or afterwards with friends, family, and preferably both, of course. If you have any feedback, you can go to the Virtual Jug Twitter handle, like @VirtualJug, or you can ping me personally. If you have feedback that is like not so positive, send me a private message. If you like it a lot, please shout it out, scream it out publicly. Well, that's enough for me. So let me just stop sharing my screen, and then we have Piotr. Hey, man, how are you doing?
Hello. Well, I'm not doing bad considering the the circumstances. I'm even doing better, I think, than most of the folks who are in the hospitals. Of course, because I'm still in this place when I work normally. I mean, maybe without this green screen behind me, but this is the place where I work work from for years. So let me just switch to these slides because I think you're not to listen about me, but Java 15. By the way, Brian, thank you for this warm introduction. Indeed,
cool.
I was. Sorry.
I said, cool. I will move over and make sure or try to make sure that you're pinned in the screen so that everybody sees your screen up front and spotlighted, and not me. So,
okay,
the floor is yours.
Thank you very much. So before we start sailing, a little explanation why this presentation is titled Sailing Java 15, because I do shorter ones like 30, 40 ones, which are called Surfing Java, because in such a short period of time, I'm just able to scratch the surface or surf on the surface of new Java stuff. When I have time, like during DevOps, to do like a 2 or 3 hours deep dive on changes in recent versions of Java, then of course I can utilize this time, and then it's called the deep dive. Today we're somewhere in between. That's why it's called sailing. So we're going to enjoy it, but unfortunately we're not going to do like a submarine way. So this is about sailing Java 15 people. It's November the 10th. It's a virtual jack session. Let's go. So briefly about myself, who am I? I'm self-employed as a remote freelance software gardener. As I said, when I work from here. Although my current job status is like 404. I blog sometimes on my page softwaregarden.dev, and I also work as a trainer for a few companies. One of them being Cementis. I've been working with Java and in Java for quite a few years. I think I've been writing code for even Java 1.3, and even when I go on holiday, provided holiday is still available, sometimes Java is right behind my back, so I can't get rid of it. I also do some bits in Scala sometimes. And before we really start, a little safe harbor statement, caveat auditoris. Everyone can make a mistake, including myself. So please don't trust talking heads on the internet. Verify on your own. Okay, so the very first question before we start really discussing the technical stuff. Shall I migrate to Java 15 or stick to the latest LTS, long-term support version, being Java 11 at this moment? So the answer is, as a proper consultant, the answer is, it depends. Because if your software is running on Java 15, you're not using any libraries causing any headaches or which are problematic to port to new versions of Java, why not use it? I mean, LTS is a business promise or a business contract. It has nothing to do with technical stuff. Of course, maybe you'd like to skip using preview features in production because these might be subject to change. Maybe we shouldn't be that eager. However, everything else, if it runs, why not give it a spin at Java 15 or whatever comes out in March and so on. So migrating to a non-LTS versions has a few pros and a few cons. And so you have to face so-called support cliff, or de facto, you need to find yourself an LTS vendor. And that's really also problematic sometimes if you're forced to use cloud providers. Why? Because sometimes they support 8 and 11 and nothing more. And if you decided to, let's say, migrate to Java 15, probably you'll have to migrate to Java 16 in March if you're interested in security updates, or you will have to find someone who will provide you updated versions of Java 15 as if it was an LTS. Of course, this also means if you have release, just like me, like an on-premise product, that using preview features is actually not such a good idea because people would need to enable them in their code, as we're going to see in a minute. Sorry, not in the code, in the JVM. And you need to recompile preview features for next releases as well. Even if you don't change a bit in your code, even if the preview feature doesn't change in any way, let's say like switch expressions did from Java 13 to 14, still you need to recompile the code. And there are also benefits from better performance. Like since Java 9, we could benefit from compact strings without waiting for Java 11. And so is the case here. We don't have to wait for Java 17, and also we don't have to worry if these new GCs were backported to our beloved Java 11 or Java 8. We could start using them right now in Java 15, and we can observe better performance if that's the case for our product, of course, without changing a bit in our code or even creating the jar file again. And it's also a better feedback for the Java team, provided you share with your feedback. And I really hope this is the case for this community. And also it means eating elephant in small pieces, because this just like a riddle for children in Poland. How do you eat an elephant? And the answer is piece by piece. So instead of jumping every 6 versions every 3 years, maybe it's worth eating this elephant piece by piece. And please remember, neither non-LTS releases or preview features are anything like monkey soft or banana soft. They are tested. They are really they are early access builds. They are release candidates. People shout out what they found out and so on. So they are not something rubbish, not tested or ridiculous. Okay, so let's talk about Java 15, because Java 14 brought us, if I'm not mistaken, 16 JEPs in Java 15. Since September this year, we have 14 new JEPs. So it's a little bit less in numbers, but maybe not in the content. There are release notes. I really suggest you should read them because RTFM people. And there's a new syntax like text blocks. There are preview features, records or pattern matching. This is a second preview feature, or sealed classes, which is a first preview feature. There are also incubator modules like foreign memory access. And we also have these new GCs, ZGC or ZGC and Shenandoah. So these are 7 JEPs from Java 15, and here are the other 7 JEPs from Java 15. My job is done. Thank you very much. Unless you would really like to see how do they perform and if they are useful for, let's say, ordinary developers, just as me. So before we dive or jump to these preview features, let me just show you or discuss this briefly, this concept of a preview feature, because like I said, for example, records are a preview feature. So they're implementation of JEP 12, and you enable them basically by using -- enable --preview, both for compiler, both for JVM when you run your jar or class files or the way you run it. And yeah, it would take too much, I guess, because we have only 60 minutes to discuss this. So I've decided to make a link for you for the other slides or for video if you prefer, where it's a precise introduction. I show how to use that, for example, with Gradle, with Maven, or with your beloved IDE or in Terminal, and how the compatibility works and so on and so on. I will just show you now one thing. So of course, this should be done in a POM and so on, or in a Gradle build. Scratch or something wasn't imported properly. So in case if you're using IntelliJ IDEA just as I do, you go to project setup, and then in this project setup for project, you should select 15 preview. Then it will show you a warning that you have to accept, like license stuff, that it won't be supported forever and so on. But sometimes there are some issues, and maybe you'd also like to do it for the modules. So if you have issues like your IDE shouting out that something is not implemented because of the language level, please make sure that for each and every module you also have this preview version selected, because sometimes somehow it doesn't propagate. I've seen such builds on my own. Okay, so that much about preview features. So let's start with a text block, which is a standard feature now since Java 15. It was also a preview feature in Java 13 and 14. And this is a string as we know it. I mean, the coloring may be not so much accurate because this JavaScript plugin doesn't know about modern Java features, but don't worry, we will see that in IDE soon. So if we wanted to have like 4 verses of a poem, this is how we used to do it, for example. So like this \n and so on, and we had to concatenate these lines and so on. And it didn't look that bad, actually. But if we had to send a JSON, an XML, or a YAML, then things start look worse. I mean, provided you'd like to have things nicely formatted, for example, something like this, because you might be, I don't know, talking to an Asian system or anything, maybe like doing that for tests, for validation. So instead of something like this, since Java 13 or 15 as a standard feature, we can just do something like this: 3 quotation marks, then we put the text, and then we close it with 3 quotation marks. And see, this gets even nicer because we don't have to escape single quotation marks. We don't have to put these nasty new line breaks and so on and so on. So defining like a JSON, SQL, XML is much nicer in this approach. And yeah, there were no changes since Java 14 as far as I can tell. So text blocks are opened by 3 quotation marks. Then you need to open a new line, and you need to close them somewhere. And this positioning of this closing matters. I'll show you that in a minute. And once created, it can be used just as any other string. So we don't have any new kind of string in a runtime or something like this. I mean, once you create a string, it's just a string. It's text blocks are only about a new way of defining or declaring or creating text blocks. So let me go back to the IDE. Yeah, so let's run this example. Yep. So I've decided to run this. And as you can see, as I told you, you can't have something like this. You need to open it with a new line, else the compiler will yell at you. And also you can't have anything like this. I mean, you need to close this string properly, else you see there are some issues with formatting. So this is how you handle them. And now what might be interesting to some people, let me close these windows and show you like maybe like this. It should be easier for you to see. Oh, sorry, it wasn't this this example. It's another one. I mean, the code is on GitHub, and you're free to experiment with it, to play on your own, and to learn, to explore. However, we have to squeeze, and I'm forced, unfortunately, by the nature of time, to show you only some things. So I'd like to show you, because this is the indentation, I think, is the most confusing thing. So let's go to this indentation test, and as you can see, we can say we can use 3 quotation marks. We just need to escape any of them. I usually escape the first one. So as you can see, you can add 3 quotation marks. And as you can see, this piece of code is not indented. I mean, this string, this is not indented, and this is not indented either. And you might be wondering, what's going on here? But I see indentation here. Why are you telling me it's not indented? See, the output is not indented. Neither this, nor this, not the first one, of course. So this is indented. This, and this is very indented. See, this, and this, and this. So indentation is dictated by the fact that it's related to, in this simple examples, to the last line, which is the closing line. So see, this is indented relative to this, not to, let's say, the outer code. That's what's important, because how the algorithm works. Of course, you can have also empty lines, and so on and so on. See these, and things get more interesting when you see an example like this. See, we have this piece of code, and this is the output. And as you can see, it's formatted differently. So what's the reason? The reason is the algorithm. It's not obvious when you take a first glance, but let me activate the white spaces, and now it's maybe more obvious. So see, it's about what's a white space. A white space is just a white space in a tab, and a space count exactly as one white space, as one character. So if we go something like this, and then how the compiler works, it tries to see if all the lines begin with a white space character. If they do, if they do, then it tries to select this first white space character and deletes this, and loops, basically repeats. So if the first character in each and every line is still a white space, then here we go again, and still we have all lines starting with a white space. So here we go again, one white space character deleted, and now we've reached a state or a condition for stop, where basically this tabs is not preceded or prefixed by white space anymore. That's why this remove incidental white spaces algorithm stops. And this is exactly the reason why we see something like this, my friends. So see, these are spaces here, and these tabs here got chopped. So that's the reason why this is not indented, but this is indented, because these two tabs got chopped, and this is why it's indented, basically. So let me revert this, and there's a bit more. So of course, once strings are created, you can concatenate them. You see they behave just like normal strings. We can add special characters to them, and we don't have any kind of interpolation, like, I don't know, $, in Bash or in Scala or something like this. What we have is a new formatted method which works pretty much the same. Actually, it works exactly the same. It's calling the same code as the string.format method, but this is based on instance, or we call it on an instance. It's not a static method, and it behaves exactly the same. You see this pattern here and here, and I'm able to this way to interpolate, let me put it that way, this string, because text blocks are no strings literals. So going back to slides, this is what I've told you. This is also what I've told you. Pretty much I've told you everything except these new 2 sequences. So backspace backspace S inserts a space which is not skipped or not trimmed from the end of a line in such a string. And if you'd like to have a long piece of text, which is one line, but you'd like to chop it into lines in your IDE just for convenience, you can still do that. I should have an example like in, where do I have it? Like in here, see? This ends up created as a single line text because I have this backslashes in here, single backslashes. Okay, yeah. So these are simply strings only without need for explicit white spaces, and they escape the same way, and so does the concatenation work, and so on and so on. And as I told you, they are not raw strings, literals, which got unmerged from Java 12. If it's good, if it's bad, I don't know. Tell us in comments. There is a very nice article, Programmer's Guide to Text Blocks, if you'd really like to understand every tiny bit of this. I'm not repeating myself because I've already told that at Devox. I know many of you have seen that. I think we'll be able to put a link to that piece of presentation either on YouTube or in Slack. So we'll get you covered. Okay, so let's talk now about new GCs, which are Shenandoah GC and ZGC. Maybe you've heard about them, maybe not. So what do? They can support heaps up to 16 terabytes. I remember my first PC having 32 megabytes of RAM, and now we have 16 terabytes of a heap. Amazing. And they are about short stop the word pauses, which should be, or in the future, there will be a constant time. Now, it's not always the case. For example, if you have many GC roots things threads, for example, ZGC will have a longer time. And what they do is that they're compacting the memory or defragmenting the memory, if you will, concurrently. That's what they do. And they are about single generation, at least now. I know there are some plans also regarding ZGC, for example, to have 2 generations again, so young and old. And they work using jitting barriers for read and for write. And there's one thing I'd like you to remember. They are not always better for your problem, for your program, for your runtime. Because of this fact that they are working concurrently, and they try to provide short pauses, they end up using more CPU. So your CPU consumption will most probably grow if you start using Shenandoah or ZGC instead of, for example, G1 or other garbage collectors. What you'll get then is these short stop the word pauses, which will make for example, your system be more predictable in terms of API response times and so on and so on. So yeah, there's a nice talk about them from Simon Bordet. And let's talk about Shenandoah. So how do we use it? Since Java 15, we just use this flag, use Shenandoah GC. There's no need for use experimental features or something like this. And of course, it's always a good habit to set a maximum heap. And of course, there are also other switches or other like parameters. This is the bare minimum, I would say. And they operate using forwarding pointers. There's a nice documentation I really recommend you to read, and even better, try to understand that. It's really cool. It's really friendly. And this is how they work. So once you have an object which has been moved from this from space into this to space, all these writes from the old references, which haven't been, like, let's say, rebound or whatever we call that in English, then all these writes and reads should be going to this new object, or let's say to this object in a new location, in this to location. And it's achieved by the fact that the header is turned into a forwarding pointer. So yeah, it's about this jitting these barriers. So basically Java discovers that, oops, this is an old copy of an object. It has been moved somewhere here. So I have to use interpret this header as a forwarding pointer. So it points me here to this object, and now I access various fields and so on. And ZGC works in a bit different way. We have a different flag or parameter to switch it on. And there's also a nice wiki page, a nice talk by Eric Österlund. And the modus operandi is a bit different. So to address 16 terabytes of memory, our processors, despite being 64-bit processors, are using only 44 bits. So the 20 bits, remaining 20 bits are effectively wasted, we could say. So instead of wasting them entirely, some folks at Oracle decided that, hey, maybe we should use 4 of these wasted bytes, give them some kind of colors, like just like quarks, for example, or something like this. And using them, basically, the Java at runtime is able to say if these objects have been moved to this new 2 space or not. I mean, the color needs to match, the color of the pointer needs to match the color of the current GC face, roughly speaking. There's a nice tutorial about ZGC. And please remember one thing, this is just really scratching the surface of these 2 new marvelous garbage collectors. I mean, they are not new. They could be seen or used even in previous versions and not so powerful. And also they are going to be still developed to add more features, to make them more robust, to guarantee shorter pauses, and so on and so on. But what I'd like you to see is, let's go to this quasi benchmark. I have a quasi benchmark. It's not a proper benchmark. It's not how you do benchmarking, really. So if you like to do a PhD and benchmark something, this is not how you do this, okay? Please don't refer and don't quote my name. I used some help from Jarosław Pałka to create this. And what this benchmark is actually doing, well, it's doing something we shouldn't be doing, which is it makes some rubbish. It creates garbage, and that's it. Basically, it makes the GC busy. And I will, please excuse me, I will not run it now. It's described how you can run it and the parameters you should use. What I'm doing here, or what I did basically, was I recorded the flight, or how these programs behaved in runtime to Java flight recorder files. So let me switch to Java mission control, and we have these 3 recordings analyzed. So of course the programs are usually working like this. So G1 is running quite long compared to Shenandoah or ZGC. But as you can see in this automated analysis, there's a problem with application holds, with GC pauses, and so on. So let's take a look in there. And as you can see, there's a very nice pattern of using this. These are like pauses and so on and so on. But what you can do is you can sort the pauses by their length, and we can discover that the longest pause took 225 milliseconds. I mean, on this machine I'm using right now, only I was doing that for a Warsaw Jack session. We had 2 hours at that time. Okay, so this is the number. So it means that for all these little periods of time, our application didn't respond, and this was the longest period, but it didn't respond. It wasn't doing anything but garbage collecting. And how things are looking for ZGC, you see there is no big red warning, so hopefully things were better. And when we go to these garbage collections, you see that the longest pause took like 1.4 milliseconds. So it's less than 2 milliseconds, right? And it was like only few of them, like 4 of them were so long, the other were sub-millisecond. And let's take a look at the Shenandoah. So also nothing red in here at the first glance. And when we take a look at the pauses, well, one of the pauses took 1.7 milliseconds, but I mind you, this was the very first pause. So it was like a warm up and stuff. So I mind you, this was not a benchmark. We didn't warm up properly. But when you take a look at the other pauses, they were also like 1.1 millisecond, and the other were sub-millisecond. So as you can see, Shenandoah and ZGC compared to G1 were like 2 orders of magnitude better in terms of the length of the garbage collecting pauses. So if you need short stop the word pauses for garbage collection, I think you should really try to convince someone, install Java 15 in production, even without recompiling your code or anything like this. Just give it a spin and see how it works. And even it might be even better to do that not in production, but in like a staging or something like this, and give it a try, collect these numbers, compare and measure, and make sure you're not degrading your application, of course. But as you can see, there is a very, very nice potential for you to use, and you don't have to rewrite anything in your application. All you can do or have to do is just to switch to Java 15, and that's it. So back to the slides. By the way, I like to remind you, as Brian said, if you have questions, please don't be afraid to ask them in Slack channel. If we won't be able to answer them during this session, I'll try to do it later. You can also, if you have like more private issues, you can grab me on Twitter or on Telegram. So let's talk about pattern matching for instanceof. It's a preview feature still. It was introduced in 14. It's continued in Java 15. And it's about this code, right? So in this piece of code, the compiler behaves like a maniac, I would say. So we ask the compiler, hey, dear compiler, please tell me if this object is an instance of an integer, because what I would like to do is I'd like to have it doubled. I'd like to double it for whatever reason. And of course, I would do something else with this doubled number, like return it or whatever. And the compiler in this very first line says, yeah, it's an integer. You're free to get in. And I can't just double it, because the compiler would say, are you nuts? It's an object. You can't just double it. Therefore, I need this, and you also need this nasty line where we have this casting and so on. So we have to be extra verbose, say, okay, now please treat this object as an integer. And when we have a reference for an integer, now we are able to double it, right? And things get a little bit easier with Java 14 and 15. Because what we can do, we can name this object, or we can give it an alias, and we can call it an integer. And using this, what we can do is just have integer times 2, and this is our result. See, so we don't need this nasty line. And things get even better, because some call it smart casting, not pattern matching, but smart casting. And I think it's a really very good name. Because you see, for such a, well, I should have that in a code. Let me see if I have it in my code. So it should be pattern matching. Yeah, right. See, so we all have string utils either from Apache Commons or somewhere in our projects, and there are odds. I mean, odds are pretty high. You have such a method that we verify that an object is a string and it's not empty at the same time. So see, what we can do is we can use the power of shortcutting and say, if this object is instance of string, then we can alias it or rename it. And this makes the subsequent calls, provided this it's connected by AND operator, not OR operator, of course. This will make the subsequent calls also able to use this str, this new alias. So I can just make sure this str is empty, not, because why not? And also for this piece of code, let me run it, because why not? See, we can ask various objects, who are you? And we get an object, and if an object is serializable, we can print it out. I mean, what's kept inside. See, like this, and so on. Everything's serializable here, and we can also use this this shortcutting. See, so if it's a string, then we can check if length of this string is at least 3 characters. We can also check if it's an integer, if this integer is a positive one, because we don't want negative integers, for example. And also we can, for example, give an alias to a long, and then we can make sure it's out of the range of -9 to 9. So as you can see, this is not only about ifs, but also about nice usage like this. That's why some call it smart casting. And I think using it since Java 15 16 will be really smart, because this should be a standard feature at the time. Okay, let's go to slides. Yeah, you've seen that. Yeah, one thing, please, really think it through if you should be using it in object equals, because using instanceof in object equals, if you have unusual inheritance structure, basically, we could jeopardize your code. So you need to know when to compare classes in in equals, and when to use instanceof. I have a blog post on my personal page explaining that. Okay, sealed classes. Sealed classes. We are seeing the first preview feature in Java 15 for sealed classes. And when should we use sealed classes? Because we don't want someone sometimes to extend our classes and also interfaces. In the name of this job, there's only classes mentioned in the title. I mean, but it's also about interfaces. So please think it's actually about sealed classes and interfaces. Sometimes we don't want somebody else to extend our classes. But we don't want to use final, because final is like all or nothing. Final means nobody can extend, provided we are not using some dirty reflection tricks. But maybe we'd like to have something in between, like I can extend, nobody else can extend, or I can extend, my friends can extend, but all the other people cannot extend. Like, for example, core team can extend and the other teams cannot extend in their code, in their services, in their like library usages or whatever. And we also don't want to reduce the visibility from public, because, for example, we like to use it in tests, or it's a part of our public API. So why should we be using like protected or something like this, or private? And all points, as I see them, are about preventing unintended or bad code reuse by applying inheritance. So inheritance itself is not bad. I strongly oppose such as saying that never use inheritance is bad, blah, 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 yada, yada, yada. No, inheritance is okay, it's misused. So this sealed classes job is about preventing such a misuse, and therefore I like it very much. Okay, so this is a piece of UML. I'm not using UML frequently, but for this very occasion, it's perfectly fine, I think. So let's take a look with me at this UML. So we have basically two artifacts, or two jars, or two projects, if you will. So this is a library, and this is a user code, like somebody is using our library. And we have our library type, let's say, I don't know, some kind of a calculator or a logger or whatever, just some utility, and it's an interface. And we want to permit only these implementations, like abstract libtype implementation, libtype implementation 1 and 2, and no-op libtype implementation, because we master these classes, we don't expect any other classes to be extending it, and so on. And also, so these are these green arrows for inheritance or implementation. Also, what we would like to permit is ordinary use by the clients or customers of our library. So we want them to include our libtypes in their code, but what we'd like to prevent is this bad inheritance, this bad usage. So we don't want them to allow to use this red arrows. So they are not able to extend or implement because it's permitted, because this type is sealed, but we would like them to use these types. So let me do something like this. It should be better for sharing also, right? And we have library type. Yeah. So this is how it now looks in Java, or can look in Java 15 as a preview feature. So see what I'm doing here. I have this library type. It's an interface, and I am sealing it. Now it's sealed interface. And I permit only this type and this type to implement or extend this interface. So this is this arrow and this arrow. And therefore, this type, so this class here is an abstract one. And of course, it's still sealed because I still want to keep this, this decision, let me put it this way, with me. So it implements library type and permits two other children to be implemented. And I have this class implementation 1 and 2, and see these are final. So final is like ultimate sealed. Nobody can extend. It's like sealed with empty permits, and final is not going anywhere. My friends. So that's why it ends this inheritance tree. And I have this sum class, and this sum class, as you can see, can use this sealed type as a field or it can use it as a memory type, no problem with that. However, what we cannot do is we cannot extend this type or implement this type because they are sealed and we are not listed in this permitted list of children or implementers or whatever. See, the warning is, what's the warning? Come on, give it to me. Yeah, it's not allowed in the sealed hierarchy. So this is how it ends up. So we either need to make it non-sealed, sorry, just like, you know, with anything, or add this type to this permits list. So it's permitted in this sealed inheritance. There's also one more switch. I have it in another example. I mean, you can opt out from inheritance, from sealing this inheritance. You can say non-sealed, and it's a nice, I don't know if it's not a keyword. It's like I don't know, some kind of indicator or something, but it has a dash or hyphen inside, and some people don't like it. Personally, I don't care, but this is like, if you'd like to, for example, make this abstract class still open for everyone, then it of course can't have this permits. And this means that when this type is non-sealed, that, as you can see, now this user lib type implementation can extend this type because it's not sealed, despite the parent of the parent being a sealed one. Okay, let me roll this back. Yeah, so this is the code I told you about. Let's move forward. About helpful null pointer exceptions. They were introduced in Java 14, but they weren't enabled by default. Now in Java 15, they're enabled by default. And what they do, we all know this code. Like, for example, we have this, some call it decorator, some call it wrapper, some call it matryoshka. We just have an object in an object in an object in an object, and we are like, when we print this code, everything is fine, everything is printed out. We get you know, the internals of A and so on, because this is how toString could be implemented. However, we pass this instance of A somewhere, and someone is doing something to our code, to our objects, because, or not code, but objects, because these are mutable. And when we try to check the length of this very last object, it throws null pointer exception, something like this. And this is what we see up to Java 13 or 14 if you didn't enable it. It just shows that it was a null pointer exception somewhere in line 37, and this is the line. You can trust me on this. And we just, you know, when you see something like this in logs, you start wondering, oh my, what's null now? Was it A or B or C or F or what's the null? So we could do two things. Some people started to chop these calls line by line, so there's only one possibility per each line to be null. But let's be honest, such code looks ugly. And the other were applying more kind of a more defensive approach, using ifs to check if A is different than null, the A dot B is different than null, and so on and so on. That looks ugly too. However, since Java 15, we can do, let me, should have null pointer, sorry, null messages. Yeah, that's the code. See, so let's run it. And when we run it, now we can have very nice messages saying cannot read field F because abc.e is null. So helpful null pointer exceptions are about this, are telling you or us what cannot be done and because of what, but they are describing the consumer. They're not able to tell us who made this E field null, because it's impossible. Like, it's not recorded, it's not stored who broke our precious E object. It just says, hey, I cannot read this field because this field or this object is null. And also it says more like, cannot assign something because this field is null, or cannot call the length because value returned from hash util hash map, sorry, is null, and so on and so on. It doesn't say anything in just three cases when we disable it explicitly from Java 15 on. when we throw NPE by our own. So when you do something like this, when you throw NPE on your own, then it's not going to show anything. And third case, when we deserialize this exception, because this message is calculated or computed or constructed on demand. It's not serialized, it's not passed. Like if you still have like AGB or something like this, you're not going to see this because it can be seen only at the machine where the null pointer exception took place. Okay. Yeah, message trying to say what cannot be done, why not done, and describing the consumer, not the producer, and it's not serialized and computed on demand. And this is the switch. If you'd like to opt out because, I don't know, GDPR or, I don't know, code obfuscation or whatever, this is how you use it. You put minus and show code details in exception messages after double X, of course. Okay, so records. We are running out of time.
Piotr, can you briefly go back to the previous slide, because it looked like your picture was hanging, although we could hear you. So then the folks can actually see what you mean. The picture for me came back when you said, but first you have to do the minus XX before.
Okay,
so,
yeah, sorry. I live in a countryside, so I don't have like fiber optics or something like this, and sometimes unfortunately internet connection hangs. Sorry for that.
No worries. But now everybody has seen the whole complete slide. So
my message about helpful null pointer exception messages is, if you'd like to disable them due to whatever reason, just use -XX and then minus and show code details in exception messages. This will make your JVM behave like it used to work before. Yeah, perfect. So records. I'm afraid I'm not going to cover records in full details because we're running out of time. However, I was talking about records this spring during all the talks. You, Brian, was also like co-hosting or that. So I think we'll put there's a whole talk about records, a whole talk of mine about records. So I will gently reroute you there for more details, or there will be another opportunity during JLove conference. I mean, normally it's in Berlin, but this year it will be free and online for everyone on December 4th and 5th. So you can, if you're eager to learn really deeply about records, I invite you there. Today we're going to, or I'm going to cover records just briefly. So they are preview feature of Java 14 and 15, and hopefully they will be standard feature in Java 16. So they are new kind of type declaration. And when I think about records, I think about them like they were some kind of relatives of enums we saw in Java 5. So enums were a new kind of type declaration, restricted, and so are records. They are classes, they are objects, of course, but they have some restrictions and some benefits thanks to those restrictions, of course. So yeah, record is a restricted form of a class and implements Java-lang record. And this is how you declare a record. So instead of a class, we say record. Then we put the name just for like every other class. And then at the end, we'll have the body of this class. I mean, nothing changes here. We can have methods, constructors, and whatnot. What's a bit different is so-called a record header. And in this record header, we enumerate or we list all the properties of this record. So based on these components, we will end up with a class that has private final fields named like this, of course, with such types. And we'll also have accessors, not getters, accessors. We'll get to that. And in code, it looks like complex like this. See, so I have a public record, and there's a complex because this is a dummy implementation of complex numbers, and they have the real and imaginary part, and you use them if you'd like to have a square root of -1, for example. And we also can have a few methods for them. So having a look like hello records, see, so there's a code using them. So I declare, create a new instance of one complex and another complex number. When I run it, this is the output I see. And I see this output, because this complex and this complex were taken together and multiplied, because I've added this method, and also I've added in my opinion, a nicer method, a nicer version of toString method than the default one, because the default one looks like this, and this is not something I was taught at university. At university, we had this I for imaginary part. So that's why I prefer to override this toString method. And then it looks like this. And let's say in your code, you'd like to access parts of this or components of this record. So let's say we'd like to find out what's the real part of this record. Then we do record.nc real. It's not get real. It's not get imaginary, it's just real or imaginary. That's why records are not bins. They're not Java bins. They don't follow, they don't, I don't know, implement in any way this getters and setters approach from Java bins. So records have a name, they have their components, but they're not required to have them, and they become these components private final fields, and they have accessors generated and generated constructors, and that's also important. They have equals, hash code, and toString. And the records, can have constructors, implementations of methods. I mean, as I have shown, if you don't like a generated method, you're free to override it. Why not? As long as it obeys the contract, of course. We can have extra methods, static fields methods. We can have we can implement interfaces. It can be generic, but it cannot extend a class. Yeah, it can extend class, be extended, and have setters, because records have these fields which are final, mind you. And yeah, they cannot have any extra instance fields, and they can declare native methods, because this would mean licking the control of the state. And please remember, records are not Java beans. They are just pujos with accessors. You can think about them. And I really like this description. They are called named tuples. So for example, in SQL we have tuples, in Scala we have tuples, but these are named tuples. They're not anonymous. So each record has its own name and type. And I really think it's cool, because then you can't mix peaches with plums, which is which. And it's really useful for nesting them. For example, they can be nested like static classes, but they can also be declared inside methods. And that's really cool. Let me show you an example. So I had this example demonstrating how to use ting collector introduced in Java 15, see, like this. And it's not about ting collector. What's important is just to use it. I had to create such a class to keep this result, to print, eventually print count and sum of the numbers from a stream, like this stream. And see, this is the class I had to declare. And now, instead of having something like this, all I need is this. And I'd like to make it important for you to see that I did this piece of code inside the main method. So this record can be used from this point until the end of this very method when it's declared. And instead of these many lines, I can have just a record, which is very nice accumulator for these ting collector, and of course also for reduce and so on. And what's also I think very cool is what we're going to see then, because records are about, like DTOs, VOs, and so on. They are about passing data around. They are not that much about the behavior in general. I mean, they are about data and the behavior related to this very piece of data, and they are immutable, and that's pretty much it. So let me show you, this example. And in this very example, I have a bean and I have a record, and I like to serialize them, and serialize them using Jackson, because many of us are doing these REST endpoints and so on. So when I try to run it, it's going to blow. Yeah, it blows because from Jackson's point of view, these are empty bins, and I'm using Jackson version 2.11 something. So to make this work, I need to uncomment these annotations. So we say that this field is a property because I don't have getter. See, I just have an accessor, and this is an immutable bean. So I need to annotate the constructor, and for the record, I need to do a similar thing here and here. And that's pretty much annoying because, of course, I should import it properly. So the imports are making this short. However, this is to make, sorry, this is what makes this code run. Hopefully, we'll see. Yeah, so it runs. See, so it just serialized the bin with just one field and serialized record with just one field. However, things will change. My friends, and let me find it. Okay, so yeah, things will change in the future because in version 2.12, and this is really nice, nice example of how preview features are working, how they adapted by community, by various libraries, by ecosystem, and so on. See what we will have in this record. We won't have this. We won't have this. We won't have this. And actually, we even don't need to have this. I'm just using it to show you when the constructor is called. So this is our whole record class. And with this new checksum, which is still not released because it's a snapshot version, see, it's still working the same. And because Java beans were merely a convention, like a promise, I behave this way and you treat me this way, we had to still to add this many annotations if we didn't have setters and getters, right? And for this is no longer a case for records. See, because we know how records behave, because we know they are just data containers and so on. We don't need these annotations for now in Jackson. And I really, really hope this will happen eventually to all the other pieces of the ecosystem, of Java ecosystem. And this is just like generics. They didn't catch up at the very beginning. And from day one, it took quite a few years. But now I think nobody thinks about having Java code without generics, right? So I think the same will happen to Java when it comes to records. Okay, so yeah, that's it for this piece of records. And there's only one more thing I'd like to show you, which is biased locking. And biased locking has been deprecated in Java 15. And yeah, it's biased locking is a legacy synchronization optimization which is costly to maintain. That's why the architects of Java think or consider removing it. It got deprecated for Java 15. And yeah, if you still like to use it because you see or you detected like a performance downgrade in your application, this is the way for you to opt out. And it's very nice article from Quarkus about Quarkus from Red Hat, describing how it works, how how it can impact your code. Sorry. And I'd like to show you that because we have, or I have this in a code. See, so this is a code heavily using synchronization. So we have some kind of contention when it comes to concurrency and so on. So let's try to run this code with locking. See, it says its option, it was deprecated in version 15 and will likely be removed in a future release. And running, crunching the strings in a string buffer. It should end up soon. Yeah, so it was running for about 17 seconds, right? However, if we use it without this opt-out, just using Java 15 defaults. Oh, sorry, it's still running the same way. So let me please edit this. Let me edit this. Let's remove this and debug. So instead of 17 seconds, we should see how many? I didn't start a stopwatch, sorry, but it should also end up soon. See, so this is just an artificial piece of code to make usage of this bias locking, basically, and it's still running. I didn't prepare any jokes, sorry, to entertain you. Oh, it finished. So it took about 25 seconds at my machine right now. So as you can see, it can kick you, perhaps. So please be aware of this. If you upgrade to Java 15 or onwards, and something is not performing as well as it used to be, maybe it's time to use this, or maybe it's even better time to try to rewrite this to make sure that bias locking is not involved, basically. Okay, so about removed stuff. So Solaris and Spark ports have been removed. They were deprecated before, and this is, I mean, the reason for many people to cry that Nashorn JavaScript engine also got removed from Java 15 after being deprecated in Java 11. And there are also more changes. I mean, we have more emojis in Unicode now, maybe other things, and I don't know. And no new emperor in Japan, as far as I can tell. There is a new implementation of is empty in character sequence, and that was a very nice case described by Stuart Marks. I recommend you reading this blog post. There's a new specialized implementation of tree maps, so we cannot use reference to the very same tree map when we try to compute keys or values or something like this. There are also more changes. We can specify a local port for JMX connections. We can also exit heap dumps now. Of course, security stuff and root certificates got updated, and many, many more. And just as Brian said about feedback, folks, really, communities are about sharing feedback. So please always provide your feedback for everyone at every event you attend in any form. I accept even paper forms. That's not an issue for me. However, for today, I prepared a little Google Docs form. It's anonymous. I don't know your names, your whereabouts, and know nothing. So even if you're not watching this online, please provide your feedback. Please let me know what you think. I'll be sharing this feedback with Brian, because why not? And this is it for today. You can find these slides here. You can find the code here. It's hosted on GitHub. And if you'd like to hear more from me, the link is repeated here. If you'd like to hear more from me, you can watch for like a future my future talks or workshops on my Twitter handle. And I think this is it. Back to the studio.
Ooh, that sounds very, very professional. Back to the studio. And now you're there, big in the screen. Let me.
Yeah, I'd like to share it with you.
Okay. Oh, that's me. Okay, cool. I'm not sure how this actually works. If you will be in the screen or I will be in the screen, but let's see how it works. It doesn't matter either way. It's not that we are really, really professional broadcasters from here.
Yeah.
We're just trying something. Anyway, thanks for that great talk. I appreciate that you squeezed it in just a single hour, because yeah, I know that that is hard. However,
oh my, there's so many questions. Oh
yeah,
my.
there are a bunch of questions, but also I found out that there are a bunch of questions that are already answered. So that's good. For instance, somebody asked, like, are there any platforms removed? Well, you mentioned that Solaris was removed and Spark was removed. So
yeah.
In the meantime, that was already answered in the chat as well. I didn't understand the question because, like, I was like, platforms? Are they removing Windows finally? But no, I cannot make jokes about that, right? I'm sorry.
Maybe. If I may, I'd like to answer one question because it remains unanswered. About these sealed classes. I cannot tell you how it works for Kotlin because I haven't been doing stuff in Kotlin for quite a while, but I can compare how it works in Scala. So in Scala, all subtypes of a sealed type need to be in the very same text file, because this is what Scala allows, basically, having many even public types like objects or traits or classes in the very same source file. This is not a case for Java, so still every public member needs to have its own file. However, this can be limited, and it really differs if we are using modules or not. So if you work in this legacy way, as some say, using this all unnamed module, then everything has to be in a single package. But if we have modules, then everything has to be in our module, basically, as we describe it. So this is a difference. And as for usages of it, I think it's about, like, for example, core domain. When we want to make sure, and I have this example actually in a code, so we can have like event. Yeah, we see. I have these events here, so we have some events, for example, and they are sealed, and we decide what kind of events we have, so that, for example, another team doesn't implement a new fancy type of event. And we have issues, just iterating over these types and so on, because the idea is that in the future, together with deconstructing records, for example, or other types, we'll be able to enumerate over them, so we won't need any like default or else to handle or not implemented cases. So stealing is about the making life easier for the maintainers of libraries, basically, or core domain artifacts, I would say, to make sure nobody is, of course, not using reflection, and that's one thing, and not trying to exploit the inheritance. Basically, this is how I see seal types in Java.
Well, let's get to a couple of quick questions, because I think there are quick answers to that. First of all, text blocks, they are not preview anymore, right? They're from Java 15?
Yeah. Since Java 15, they are standard feature. Yeah.
Okay, cool. I mean, it is common now that it has that every feature has two, like every major feature has two previews, and after two previews, it will get main. So that is as far as I know from Brian Getz and from Stuart Marks, that is the sequel nowadays. The tools you were using for the garbage collection thing. What was it?
It was, my friends, and you should use it. That's one of the reasons why you should migrate to Java 11. It is, my friends, JDK Mission Control.
Mission Control. I was like, sorry. Flight Recorder. No, it's not Flight
Recorder. Flight Recorder. Yeah. Flight Recorder is the thing embedded in Java. I mean, and it's free since Java 11. And basically, this is in your JVM, so you're able to record some files. So if I had this, let me switch rapidly. So quasi benchmark. See, so when I'm calling this, I start.
I still can only see you. I cannot see you.
Oh, sorry. Yeah, I forgot. Let me switch back to this. Yeah. So it's back this example. Thanks for letting me know. It's back this example with this quasi benchmark. So I'm using Flight Recorder. I'm telling my Java process to, just like a Flight Recorder, like so-called black box, which is usually orange in an airplane. I'm just telling it to please record stuff on disk and to this file named G1JFR. So this file ended up recorded here, as you can see. Normally it should be somewhere else, and not TMP, of course. And then having this file, I can open it in Java Mission Control, and it provides me automated results of how things were doing. So this is like the first entry point, and you see the red things. And then you can analyze more stuff. So for applications I usually do, it's more like socket IO is usually very, very high. If you have memory issues or thread issues, you can analyze them. You see, for example, like what's the most used object, and it's the array of bytes, and so on and so on. So it's really very nice for like in-prod profiling.
Yeah, and it's all embedded since Java 11, if I'm not mistaken.
It was embedded even before, but it was a commercial feature. I mean, it got open sourced by Oracle since Java 11 because of this new cadence. So we had to paid license to use it legally before.
Yep. All right. Let me get to a couple of them. Oh, that was an interesting. I'm not sure if it's relevant, but are there any hacks to run JDK 15 in, for instance, an old JBoss instance? I mean, the person asking here is like, yeah, but JBoss 7 is still out, so can I update to newer versions? Is there a way?
And that's a tricky question, and I wouldn't go that far to Java 15. I would say first try to run it using Java 11, because I don't think. I mean, some stuff like from the unsafe class got still deprecated or removed, but the biggest jump was from Java, first in Java 9, and then in Java 11, because for Java 9 and 10, these Java EE modules were still there. I mean, embedded in JVMs, but they were disabled by default. We could enable them. However, in Java 11, they are gone. And if your JBoss relies on stuff from unsafe, SunMISC unsafe, which is gone, then I'm sorry, there's no way to run it. That's why, like, I don't know, there's Apache Spark and also other things which are difficult to run on Java 9 and onwards because of that, because of SunMISC unsafe. But you were told not to use it, right? So
it was called unsafe for a reason, perhaps. But maybe that was the first hint.
Just a hint.
Do you know if these garbage collectors like Shenandoah and ZGC are backported to older versions?
I mean, I'm not tracing this super duper intensively how they are backported, because for me, garbage collection is not such a big issue. I mean, performance wise, I mainly have issues on this socket.io. I know they are backported. I think Shenandoah has been backported to latest update of Java 11. I would need to check how it works with Java 8, because, for example, Shenandoah 1.0 was backported even to Java 8 for ZGC. I can tell one thing, though I didn't say that explicitly. If you're still using 32-bit architecture, then of course ZGC is not for you. Then you have to use Shenandoah. And also another thing, Shenandoah is done by Red Hat, and ZGC is done by Oracle, and sometimes politics kicks in.
Yeah. So it can also be different, like depending on which vendor you from which vendor you get your JDK. It can also that's also the case when you talking about performance enhancements. Some things are generally there in OpenJDK, but it can also happens that in some cases some other JDK is faster or not faster. I think we will leave it at this, because these were the specific Java 15 questions. All the questions are still in the live session chat, and I know Piotr is always eager to answer these things if he can. I know you're always active during other people's sessions, so
yep, sorry about that.
No, not sorry. That's what community is about. It's not just like the presentation and doing the presentation, giving the presentation and listening to streams, but it's also like interaction and asking questions. And I believe even though some questions might be very easy to answer for some people, other questions for other people, it might be something completely new. So feel free to ask these questions, and somebody will jump in to answer it eventually. For those who were pinging me on the JetBrains licenses, because I know giveaways are always hot. They're in the general channel. There is a raffle going on there. Just if you can't find it, scroll it up. It's called JetBrains License November 2020. You just have to enter it, and automatically we will draw 3 lucky winners. And I think I moved it on to the November 16th. Don't know the exact time, but make sure that before that date you entered, we will pick 3, and I will send you the codes. So you will have a 1-year license to one of the products of JetBrains that can either be IntelliJ, IDEA, or some of the other ones. So hopefully you're lucky and enter that raffle if you need it, if you want it. We only have 3, so no, not 300, unfortunately. Well, I think we'll leave it at that. Thank you so much for giving this presentation. I think it was interesting to see some deeper insights, and I know that you can talk for hours on this. But yeah, thank you so much for doing this. If you want to see this back, this video is live right away. So watch it, rewatch it, share it, and tweet it, post it, whatever you want. Feel free to do that. I'm moving on from here. Thank you, Piotr. Amazing talk, definitely.
Thank you, Brian.
All right.
Brian. Thank you, Brian.
Folks, I'm not sure which is the next talk yet, but I know that in December we already have some talks planned. So keep track of the schedule and keep track of our Twitter account, because we will post it both on Twitter and on Meetup if we have new meetups and new virtual talks going on. From here now, I will say thank you for watching, and see you folks all later, and see you later in the Slack chat. Bye-bye.